Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of work on positives and negatives with the Batty Boffin today. To help us, we have got this little picture here, which is a picture of you with a bag of peanuts in your hand, and you're walking along this yellow brick road with two magic portals on it. The first portal is a doubling portal, so it doubles anything that goes through it. You put 10 peanuts through there, you come out with 20 peanuts, okay? The second magic portal does negative, it negates anything, it swaps it to the other. So if you go through there with big feet, you'll come out with small feet. If you go through there with positive 5, you'll come out with negative 5. There's actually a button on your calculator that does it. If you look on your calculator, hopefully you'll find a button either that looks like that or one that looks like that. They both do the same thing. And what they do is they will negate something. If you put 5 in and press that button, you'll get negative 5. More importantly, if you put negative 5 in and press that button, you'll get positive 5 back again. So negate just swaps the sign. Positive goes to negative and negative goes to positive. So let's see what happens when you go through these two magic portals with 3 peanuts in your bag. Okay, so we're going to start off with 3 peanuts. You go through the first magic portal, pretty obviously you have got 6 peanuts in your bag. And that's right, because 3 times 2 is 6. Yeah, we knew that. But we didn't want to, we wanted negative 2. So now we need to negate it. So you take your 6, you put it through there, and you come out with negative 6. Yeah, I think okay with that, aren't we? 3 lots of negative 2 is negative 6. Yeah, that's fine. It gets a little tricky when we have a few more negatives in. So I'm just going to rub those down. And this time we're going to start off with a negative number. Let's start off with, oh, I don't know, negative 4. Okay, so you go through here with negative 4 peanuts, which is not going to please any elephants you meet along the way. Negative 4 peanuts, okay? And we go through the double portico, okay? So that comes out with negative 8, that's okay. But that, of course, you've just done negative 4 times 2 there. Negative 4 times 2, yep, we're happy that that's negative 8. But it wasn't supposed to be times 2, it's supposed to be times negative 2. So now we need to negate our answer. You put negative 8 through here, we come out with positive 8. Negative 4 times negative 2 is positive 8. Okay with that? We think about that, it does actually make sense, because 4 times 2 is 8. We're all happy with that. Okay? That's a positive number times a positive number gives you your normal positive number. If we make one bit of the question negative, we've changed a sign in the question, well obviously we have to change a sign in the answer as well. That makes sense. You change a sign in the question, you change the sign in the answer. But what happens if we change the sign in the question again? Well, we change the sign in the question, again we have to change the sign in the answer. And we end up with positive 8. And that is how it works. So for any multiplies or divides, actually the easiest way to do it is just forget all the negatives for a start. Okay, just pretend they're not there. Do the multiply or the divide and get your answer. A 4 times a 2 is always going to be an 8. Whether it's positive or negative, you're always going to end up with an 8. So forget all the signs, work out what the answer is, and then go through and say, every time we changed the sign in the question, i.e. made it a negative, we changed the sign in the answer. So I'm going to wipe down the board and then we're going to have a go at a few of those. See you in a minute. Right, here's a few for you to have a go at. So remember, just ignore all the positives and negatives for a start and just find out what the number is. A 4 times a 5 is always going to be a 20. I've got some divides here too. So a 12 divided by a 4 is always going to be a 3. So pretend that they're all positive and get the answer, and then look through. And every time you've changed into a negative in the question, you have to change the sign in the answer. So here you're going to change it once, here you're going to change the answer once, and then you're going to change the answer twice. Okay, so those two ones there, have a go at those and we'll look at those together. Right, let's go through those. Easy peasy. A 4 times a 5 is a 20. We changed the sign once in the question, so we changed it in the answer. Similarly here, this is also going to be a 20. We changed it once in the question. We changed it again in the question. So there we go. A negative 20 and a positive 20. Yep, that makes sense, doesn't it? They can't be the same answer, those, because they're different by a negative. So the answers must also be different by a negative. Here again, we've got some takeaways. We've got a 12 divided by 4 is a 3, but we changed the sign in the question, so we changed the sign in the answer. Here we've got another 12 divided by 4 is a 3. We changed the sign in the question, and we changed it again in the question. So there we go. Happy with those? Good. Have a go at the blue ones now, please. Right, let's go through those. We've got a 3 times a 6 at the top, which is always going to be an 18. And that means it's a negative 18. Here we've got a divide. 8 divided by 2 is going to be a 4. And that means it's a negative 4. Here we've got a 15 divided by a 5. That's going to be a 3. That would make it a negative 3. And that one flips it back to positive 3. You don't have to put the plus there. I've put it there just to make sure we definitely know it really is positive. Here we've got 3 digits. That's absolutely fine. A 1 times a 2 times a 3 is going to be a 6. That would flip it to negative 6. That one flips it back to positive 6. And that one flips it back again to negative 6. Did you get that one? Great. Okay, that's enough for this video. I'm going to come back in the next video with just a little more practice on some multiple ones of these with, I don't know, lots of bits everywhere, bits on tops of fractions and things like that. So I'll see you in the next one. Bye for now, Batty fans.